Why is that Galileo Galilei considered to be the father of modern science? Galileo Galilei is considered to be the father of modern science. He is responsible for the scientific method, which is a systematic approach to objectively test a hypothesis and formulate a generalization about certain physical phenomena. He led in promoting experimentation and the use of data in order to state natural laws. He used the same method to draw up his ideas on the heliocentric theory of planetary motion, kinematics, and the concept of inertia. His scientific method helped galvanize the scientific revolution.
Because he was a great writer and a very good self-publicist. The work of Kepler are very difficult for modern readers, even modern astronomers, to understand today. Other technical works by people, like the mathematician who laid the foundation of his work, of other scientists who preceded him or outdid him, are also complex and very dry for modern readers. But Galileo's work are clear and accessible. This is why he tends to be lionized by modern popularizers of the history of science, like Carl Sagan and Neil deGrasse Tyson, because he is more read than any of his contemporaries. Finally, popular history still likes the 19th century concept of the great man, the towering figure who appears from nowhere and changes everything, advancing the course of human progress as he does so. Historians know history does not actually work this way, but the great man narrative makes for a better story and is easier to tell that the more nuisance complex the messy reality that is actually history. So, ultimately, that's why Galileo is called the father of modern science, because it makes for a better story, even though it's wrong. Galileo was a remarkable early scientist and a great and significant figure in history of science, but he is not the father of modern science, nor was he many of the other things he claimed to be.
What is the role of paradigm shift on evolution of science, specifically on cosmology? Paradigm is a fundamental set of ideas for comprehending the world around us, and this is a set of models for interpreting, organizing, and categorizing data. In addition, there is a context for all thinking. Paradigm decide which question cannot and cannot be asked. Paradigm shift this happen when one paradigm crumbles and it's replaced by another, and when the old paradigm encounter a significant problem or information that is unable to solve or explain, it is replaced.
Ptolemy and Aristotle, basic scientific paradigm of ancient and medieval Europe. Aristotle, Greek philosopher, 384 to 322 BC, established fundamentals of logic. Ptolemy, Greek astronomer, from 87 to 150 AD, developed a system for predicting movements of planets based on geocentric or the Earth-centered universe. Features of Ptolemaic and Aristotelian paradigm. The Earth is at the center of the universe, and the heavens are flawless. Hence, everything in the heavens is a perfect circle or a sphere, because Earth is clearly imperfect. It differs greatly from the heavens, and the vice versa. Impersonal observation can be completely trusted. We know the sun revolves around the Earth because it appears to do so. The best source of knowledge is ancient thinkers, particularly the Greeks, Romans, and the Bible. Some aspects of the universe are inherently mysterious and can only be known by God.
Dismantling the Aristotelian Ptolemaic paradigm. Because of astronomy, the old paradigm is disintegrating. Ptolemy devised a complex system for explaining and predicting the motions of the planets in the sky. For centuries, this worked well, but by the 1400s, his system had become increasingly unworkable and unreliable.
Nicholas Copernicus. In his book,
On the revolution of heavenly spheres, 1543, he proposed that Ptolemy's problem could solve by putting the sun at the center, heliocentric universe. Still mostly stuck in the old paradigm, kept planets moving in perfect circles based on ancient texts. Unfortunately, his system performed worse than Ptolemy's in predicting planets.
Galileo Galilei, believing Copernicus was correct, he set out to prove it. Used a telescope to demonstrate that the moon was not a perfect sphere. It had mountains and craters, and that not everything circled the Earth, moons of Jupiter. Discovering Jupiter's four largest moons demonstrated that the ancients did not know everything there was to know about heavens. They also conducted experiments that disproved Aristotle's theory that light objects fall faster than heavier objects.
Johannes Kepler had a very bad luck life. Tycho Brahe of Denmark inherited Europe's best astronomical observation 1546 to 1601. It was demonstrated that the motion of planets could be perfectly predicted if we assume that they traveled around the sun in ellipses rather than circles. Kepler's laws of planetary motion are mathematical formulas that describe the motion of the planets. This demonstrated two things. First, the ancients were incorrect in their belief that the heavens were made up of perfect circles and spheres. Second, it was possible to create mathematical formulas to describe how the universe worked.
Isaac Newton, acclaimed for his works in optics, invented calculus as did Gottfried Wilhelm Uson Libris at the same time. We now use Libris notation system rather than Newton's. In 1687, he published his Principia, full title Philosophy, Nature and Principia Mathematics, primarily concerned with gravity and planet motion. It was demonstrated that gravity in all occasions, both on Earth and in space, could be described using simple mathematics formulas. This gives us the concept of universal natural law, but there are scientific laws that apply everywhere, always in all places.